So now that we have defined what a function is and we've looked at several examples of how to evaluate functions, we can now take a look at operations on functions. So the first thing that we can do is talk about the sum of two functions, or the sum function. So f plus g of x is simply add the outputs for the corresponding input. Likewise, if you want to find the difference of two functions, you subtract the outputs. So f minus g of x equals f of x minus g of x. Now, there's a subtlety that's going on here. F plus g is a new rule. So f is the name of a function, g is the name of a function, and then f plus g is a whole nother function. We can also look at fg of x, which fg is another function that simply means we're going to multiply the outputs. And then likewise, we can divide outputs. The only additional thing that we have to worry about here is that we cannot divide by 0. So in this example, we want to find f plus g of 5, and we've been given what f of x and g of x each are. So f of x, evaluated at 5, we will be looking at f of 5. So that will be 5 minus 2, which is 3. Likewise, g of 5 will be 5 squared minus 4, which will be 25 minus 4, so we have 21. So what's f plus g of 5? That's f of 5 plus g of 5. But f of 5 plus g of 5, we've said f of 5 is 3. We've said g of 5 is 21. So we add those outputs and we get 24. So here we need fg of x. So we are looking at multiplying the outputs. So fg of x is going to be f of x times g of x. But f of x is x, g of x is the square root of x. So we just multiply those two. So we get x times the square root of x. Now we need to find the domain of this function. So the way to find the domain of one of these functions is to look at them separately first. So we'll look at the domain of f, we'll look at the domain of g, each separately. So the domain of f, we'll look at f of x equals x. What inputs could we have there? Anything. X can be anything. But now, if we look at g of x, we are looking at the square root function. Well, if we're looking at the square root of a number, we can only take the square roots of those things that are non-negative. So we will be looking at 0 to infinity for the domain there. Now, to find the domain of f plus g, we look at where those two overlap. So the domain of f plus g will be where negative infinity to infinity overlaps with 0 to infinity. So what are the shared values there? It's 0 to infinity. Be careful and don't just assume the domain from the output here. You have to go look at where these two functions each exist, and then look at where they overlap. So let's look now at f over g of x. So f over g of x equals f of x over g of x. So we have f of x over x squared minus 9. Now we can simplify this. X minus 3 and x squared minus 9 share a common factor. Notice x squared minus 9 is x plus 3 times x minus 3. So we have 1 over x plus 3. So what's the domain of f? What's the domain of g? Look at where they overlap. So what's the domain of f? Well, we can subtract anything from an x value, or we can subtract 3 from any x value. And so the domain of f is negative infinity to infinity. What about the domain of g? I can square any number and always subtract 9. So the domain of g is negative infinity to infinity. So these overlap everywhere. But we don't want g of x to be 0. Why not? Because we are dividing by g of x back here. So what's g of x? It's x squared minus 9. So we need to look at x squared minus 9 equals 0. Now we could factor and set each factor equal to 0, or we could use the square root principle. Either one is sufficient. Either way, we have to exclude negative 3 and positive 3. So the domain of f over g takes into account two things. Takes into account negative infinity to infinity, the overlap of the two domains from up here, and then also the fact that we need to exclude positive and negative 3. So this means that the domain of f over g is negative infinity to negative 3, union negative 3 to 3, union 3 to infinity. Notice we have a break in our domain at the two values that we excluded. It's not enough to go and look over here and see what we needed to exclude, because this was simplified. We have to go through this process of looking at each function individually, and then because this is a quotient, we must look at where the denominator would have been 0.